Hello everyone, I'm going to show you how to derive the finite geometric series formula today from a geometric sequence. A geometric sequence is simply a sequence of real numbers that are multiples of each other for a common ratio r. So they can be described by this common formula, u sub n equals u sub 1 times r to the n minus 1. As I mentioned in my arithmetic series video, the reason why we have an index of n minus 1 instead of n is because that when we want to plug in n equals 1, we can end up back with the original term u sub 1. For this case, if we do that, u sub 1 equals u sub 1 times r to the 1 minus 1, and we get simply that the common ratio is being raised to 0 power. Anything raised to 0 power is 1, so we get u sub 1 back. And as usual, we assume that we have n terms, and here we define that u sub 1 is the initial term and r is the common ratio. So the trick in order to derive the finite geometric series formula is very similar to that of how we did the arithmetic sequence formula. We're going to create two copies of S. So although there's a u sub 1, we can make the same simplification that we're not going to care about u sub 1 just because every term has u sub 1 as a common factor. So we can factor u sub 1 out. And we're going to write 1 plus dot 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 plus r to the n minus 1. Now, the second copy is almost going to be the same, except we're going to multiply by rs, which means all these terms over here are going to be translated, are going to be boosted up by a power of r. So you will no longer have the starting term of this sequence being 1, but rather r, or u sub 1 r. And you will preserve the rn minus 1 term, except the last term will be r to the n. And now here comes the trick. We're going to go and take this rs equation and subtract it by this s equation. So we'll have a common factor of u sub 1, which all of these equations have. But rn plus dot 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 plus rn minus 1 plus r. And that is minus r to the n minus 1 plus dot 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 plus r plus 1. As you can see, all these little terms in the middle here, rn minus 1, r, and so forth, will get canceled out. All that will be left is the r sub n and the 1, which are unique to the s and r sub rs equation, respectively. So we'll end up getting, rs minus s equals u sub 1 times r to the n minus 1. Okay, for the negative sign distributes over here to this contracted finite expansion. Now we can just factor out s from here. So s times r minus 1 equals u sub 1 r to the n minus 1. Divide both terms by this common factor r minus 1. And voila, there's our finite geometric series formula. Now, we're also able to, though this can be done in another way, we're able to go and write out this as 1 minus r to the n divided by 1 minus r. That's pretty easy why that can be the case. You just multiply and divide both sides by -1 over -1, thereby causing a sign change to happen here. You'll see both versions of this formula in typical high school math exams. But yeah, that's it. We're done.